Hey everyone, welcome back to Directed Tech. Today we are diving back into the world of desktop CNC machines. And specifically, I've got the WizMaker Artisan 01 on the bench. I'll walk through what it's all about and how the assembly went. And then we'll go through a series of real world test projects so you can see what it can do. After that, I'll give you my take on the pros and cons and whether I think it's a good purchase for makers like you and me. Let's get into it. First, let's talk features and specs so you know exactly what you're working with when you get the Artisan 01. According to the manufacturer, the working area is 420 by 420 by 90 millimeters, and the spindle speed is listed at 12,000 RPM and 300 watts of power. Maximum feed speed is listed at 200 millimeters per minute, and the net weight is approximately 26.8 kilograms, which is just shy of 60 pounds for us here in the USA. It uses a 32-bit open source control board and supports software like Candle, UGS, IOSender, and others. For material compatibility, we have plywood, MDF, solid wood, acrylic, carbon fiber, aluminum, copper, and stainless steel. Not to mention that it's also upgradable. There's the option to add a 500-watt spindle upgrade, a fourth axis rotary, a dust collection system, and a CNC vise, all of which I will show in this video. I'd like to thank WizMaker for sending this unit and the accessories for me to review. As is custom with my review videos, although this equipment was sent to me free of charge, I have not been paid for this review, and WizMaker has no editorial control over the content of the video. They will not see the review before it is made public. I'd also like to thank my colleagues for this very special shop apron that they gave me when I retired. Thanks, team. So on paper, this is a fairly capable desktop CNC machine with a reasonably large work area. It has an upgrade path, and you can work on metal as well. In the next section, I'll share how the assembly process went. Okay, shrinking the theory into real life. Here's how the assembly went. All of the items arrived well packaged in boxes with plenty of foam. Each unit includes a small pamphlet with installation and usage instructions. For the main unit, there is also an electronic version in PDF form that is included on the USB thumb drive. The assembly of the CNC was pretty quick and painless. Simply attach the X gantry to the Y-axis and install and tighten 8 M5 screws. This is followed by some cable management, connecting the motors and control connectors, which are all color-coded and easy to access. Next, the spindle holder is attached to the Z-axis using 4 M6x60 screws, and the spindle is inserted and tightened. Connect the spindle to the power port on the Z-axis, and then it's time to move on to the final step, which is attaching the bracket for the offline controller. Overall, the first impressions of this machine were very positive. It has linear rails for the X and Z axis, girthy linear rods, and lead screws for the Y axis. And all the controls are right where you'd want them to be. The machine is very rigid, and it comes with all of the accessories you'll need for your first couple of projects. We'll talk more about the accessories a bit later on. That said, if you're newer to CNCs, I'd recommend taking your time here and verifying everything before cutting. So that's the setup part. Next, I'll walk you through a series of test projects I ran. You'll see a mix of flat carves, 3D carves, metalwork, and the fourth axis rotary. Let's dive into each one. The specs, fit, and finish all sound and look nice, but the real test is the performance. I ran through 8 different tests or projects with the Artisan 01, so let's discuss each of them in order. The first carve I tried was a sample file included on the USB stick that is provided with the machine, which used the 0.4 millimeter flat end V-bit, which also comes with the Artisan 01. The README file states that the settings are for hardwood, but I carved this in pine, so it could have been faster. It took 2 hours, 40 minutes, and 44 seconds to complete the run. Here are the final results. You can get incredible detail using a bit like this, but it will definitely take time, and you do have to be very careful not to break them. Next, I did some test carves with a 1/8" flat nose end mill. I used this first to get a feel for good speeds and feed settings. This isn't one of the included bits, and if you want to do more than very shallow engravings, you'll need to start building up your bit library. I'll link the bits down in the video description. I set up the zigzag pattern in Aspire and varied the RPM, feed rate, and depth of cut to see what settings I'd be safe using in further projects. Let me show you the results. Speeds and feeds are always a fine balance, and I was trying to balance speed based on the recommended settings from the end mill manufacturer, given the constraints of the spindle speed. The tests with a 1 mm depth of cut had some signs of chatter, and the corners suffered in quality, so I decided to back off a bit with a less aggressive 0.5 mm depth of cut. The two test patterns on the right show these results. With this information, I was ready to move on to my next project. My second project was a very small pumpkin catch tray using the same 1/8" flat nose end mill. I simply took a vector, loaded it up in Aspire, and set up two tool paths. The first, a pocketing tool path, used the more aggressive 1000 mm per minute feed rate, 9000 RPM, and a 1 mm depth of cut, since I was going to remove a good amount of material. This was followed by a less aggressive profile tool path to cut out the tray, leaving some tabs along the perimeter. Although I didn't record the actual runtime, Aspire estimated the total job at 1 hour and 34 minutes. This test, like the one before, was run from the offline controller. Here is the unfinished result of that project. My third project was this alien key 3D carving. This project started as a vector in Autodesk Fusion. I extruded the shape and then chamfered the edges since I wanted to carve a 3D design. This was saved as an STL file and then brought into Aspire to generate the tool paths. This job required 3 separate tool paths. The first was a rough cut of the tapered edges using the 1/8" end mill. This was followed by a 3D finish pass using a 1/8" 1 mm radius tapered ball nose. I'll also link the set of tapered bits down in the description. The final pass was a profile pass to cut out the carving. For this job, I used a free program that I highly recommend. It's called G-Sender. This is the same software that I use for my long mill CNC. It's loaded with features, and it's quite a step up from Candle, which is the CAM software included with the machine. It will frame your projects, show you an estimate of the time you have remaining on a job, as well as a runtime completion message. This project shows one of the limitations of using a machine with 1/8" bits. The wood is just over 1/2 of an inch thick, and it's right about at the limit of the cutting depth of the end mill that I had. In fact, during the test profile cut, a few of the arms actually broke, and I had to glue them back together. Now, this is partially my fault due to the model placement and the grain orientation. Here is the final result. It was lightly sanded after I removed the tabs. The fourth project I tackled, and that's putting it lightly, was this veteran plaque. I say that because I decided to use a very warped piece of wood to do this 3D carving. Due to the variations in surface height, I placed the model fairly deep into the wood so that everything would still engrave properly. This project included a roughing pass using the 1/8" end mill, which took about 6 hours to complete. This job was run from the offline controller. The feeds and speeds I used for this tool path were 1500 millimeters per minute, 9000 RPM, 0.75 millimeters pass depth, and 35% step over. Once that was done, I loaded in the same 1 mm radius tapered ball nose bit that I used in the last project for the finishing pass. This pass ran at 1400 millimeters per minute, 10,000 RPM, and 20% step over. It took a bit over an hour for that part of the project to finish. I trimmed off the rough edges on my table saw and gave it a light sanding. Here is the final, unfinished result. Using a finer tipped finish bit would have given crisper details at the expense of time. The last project I ran before swapping spindles was engraving this aluminum dog tag. Using the CNC vise that WizMaker provided, I clamped down the dog tag in the vise and set the Z0 height by hand. Metal engraving like this is a bit tricky since you are dealing with very shallow depths and tight tolerances. For this engraving of my channel logo, I used one of the included 0.2mm V bits and set the depth of cut to just 1/10 of a millimeter. The feed rate was 600 millimeters per minute and the RPM was set to 12,000. As you can see in this example, there was a portion of the design that didn't engrave, so I ran it a second time after adjusting the Z0 height. The job completed successfully, and it shows the repeatability and the accuracy of the machine. At this point, I was ready for an upgrade, so I put in the 500-watt spindle. The upgraded spindle comes with a new holder, but it fits in the same one that the 300-watt spindle sits in. The hardest part of the upgrade was running the new power cable through the drag chain and reattaching it. I found it was easiest to just completely remove the drag chain, open the clasps, seat the new wires inside, and then return everything back to normal. I did choose to leave all of the original wiring, although that is up to you if you opt for the more powerful spindle. With this complete, you'll just need to attach the control signal wire and the connectors to the motor controller and the CNC controller boxes. Let me pause here to talk about a few things that you need to know about the 500-watt spindle. First, once this is installed, you no longer have the ability to set the RPM via software. The control signal switches on the spindle, but speed is then set manually with the knob on the front of the spindle control box. The knob only has two markings, min and max, so you have no idea what the RPM is. I bought a digital tachometer and made marks with a Sharpie so I'd have some reference points. The 500-watt spindle runs at 10,800 RPM at max settings. With all of that complete, I ran another speeds and feeds test. Using the 1/8-inch downcut end mill, I was able to bump up the speed to 1,500 millimeters per minute at a 1mm depth of cut and still get pretty good results. Now, instead of running another carving using the more powerful spindle and the same 1/8-inch bits, I chose to see if the machine could handle a 1/4-inch bit. Now, if you choose to take that same adventure, there are a few parts that you'll need, and I will link those in the description below. With all of those upgrades complete, I decided to challenge the machine with this Compass 3D carve. For this carving, I opted for a 1/4-inch 2-flute downcut bit from 5 pairs and a 1/4-inch 1/16-inch radius 3.6-degree tapered ball nose bit from Iowa. Hopefully that's how you say it. I don't know, but I'll link it below. Now, I do want to say that nowhere does WizMaker talk about using larger bits with this machine, but I wanted to get beyond some of the limitations that you'll experience with smaller bits. Again, I loaded up a 3D model in Aspire, and I built my tool paths based on the manufacturer's recommendation for chip loads. The roughing pass using the downcut bit ran at 550 millimeters per minute, 10,000 RPM, 1.26 millimeters pass depth, and 40% step over. G-Sender estimated that this path would take over 6 hours to complete. I was able to bump up the speeds while the job was running and managed to get the runtime down to 4 hours and 25 minutes. That is one of the advantages to using G-Sender. I then installed the tapered ball nose bit, reset the Z0 point since I still had a good starting height, and let the job run. This portion only took 2 hours and 2 minutes since the downcut bit had already done a lot of the heavy work. Here's a look at the final carve. I have not sanded this yet, so you can get a feel for how things look straight off the machine. The final project I chose to embark upon was this Venus de Milo bust. Using the 500-watt spindle and the 4th axis rotary device attachment, I was able to accomplish something that I've never done before on a CNC machine. Now, I do want to say that this took a good amount of learning on my part. I devoted an entire day to this little project. We'll touch upon the software later on, but it is a very important consideration should you choose to purchase a rotary device for any CNC machine. There are only a handful of software programs that have the capability of generating toolpaths for a carving like this. This bust is an example carve included in the tutorials for Desk Proto, and I couldn't have made it without the great guides that they provide. The G-code, which is the text file that all of these programs generate for the machine to execute, also needs a fourth axis capable program to send to the machine. G-Sender, which I'd used during several other projects, doesn't recognize the Artisan 01 as a 4-axis machine since it uses standard Gerbil. It will send commands, but it replaces the 4th axis, or A-axis, with commands for the Y-axis, since many CNC machines will have you disconnect the Y-axis and plug a rotary device into that channel's controller. After a lot of research, I was able to find I/O Sender, which properly sent the commands to the machine. Although the offline controller is capable of executing 4th axis G code, I wasn't able to get it to run this code. With I/O Sender connected and the machine loaded with a 1/8" ball nose bit, I ran the roughing path, which cut down my square stock of poplar. This took over 6 hours to complete. I probably could have sped up some of this, but being new to rotary engraving, I was being pretty conservative with this process. One of the tricks with rotary carving is setting the 0 points. WizMaker includes a locating pin with the rotary device, and I use the offline controller's 0 calculation function to find the Y0 point. Z0 is also set using the pin, and I manually set the X0 point based on the size of the piece of wood that I had loaded. When the first tool path was finished, the machine returns to the XY0 point and a safe Z height. I was able to use the tail stock as a Z0 height since it should be at the material center to set my new 0 once I'd loaded up the 0.75 radius tapered ball nose bit for the finishing pass. This job took 1 hour and 51 minutes to complete. Here is the finished result of my very first CNC rotary carve. The details are quite amazing. This hasn't been sanded or smoothed at all, but it feels like it has. You really have to see it to believe it. Well, that was a lot, I know. But I really wanted to give this machine a thorough workout before presenting it to my viewers. I'm going to cover the pros and cons now, but I'd like you to stick around afterwards so that I can share some additional thoughts about this and any CNC machine before we wrap things up. Let's start with the pros. First, it's a very good value for the feature set. You get a pretty decent sized work area with this machine. You won't be building furniture, but you can make some pretty impressive decorations and functional devices with it. Second, the build quality is solid. The frame is rigid, the motion is smooth, and the offline controller is really a blessing. It takes a bit to decode some of the functions, but the manual and operation guide will step you through them. One of my favorite things about this machine is actually the dust collection system, which is available. It's an extra purchase, but don't buy this thing without it, seriously. It performed wonderfully during all of the tests that I ran. It's not too bulky, it's relatively quiet, and the magnetic dust shoe is absolutely fantastic when it fits, but more on that in a little bit. Next, the ability to upgrade to the 500-watt spindle adds speed and capability. Next, the knobs on the X, Y, and Z axis are a great addition. There are plenty of times where you might want to move the machine without powering it all up, so these things definitely come in handy. And finally, it's a great size. For home hobby workshop use, you get serious compatibility without committing to an industrial footprint. Although I might not recommend it, it's actually small enough and quiet enough to run inside. The first few tests I ran were actually done in my studio. Now let me expand on that quiet point just a second here. I'm going to turn on the spindle, 500 watt, max power. There you go. It's running, max power. Now obviously it's a little noisier if you're cutting wood. And the vacuum or the dust collection system, think like a vacuum cleaner versus a shop vac. Let me turn that on really quick. There you go. Everything's running. Obviously, this mic isn't intended to pick all of that stuff up, but I bet you can still hear me over all of this. So there you go. It's relatively quiet. I can tell you it's a lot quieter than my full-size machine. Those often use a trim router for this instead of a spindle, so they are much louder. And I have a shop vac for a dust collection system, and that thing just screams. And now for the areas where this fell short. Here are my cons. My biggest con with this machine is the software support, but let me clarify that. CNC machines are complicated, and there is a lot to learn to get one up and running. You will have to invest in additional software to make them work, and that is not unique to WizMaker. The included software, Candle, is only used for sending G-code to the machine. You still need software like Aspire, VCarve, Carbide Create, Easel, or the like to design anything. These programs can cost hundreds to thousands of dollars, although there are free versions available. What I mean by software support is that the operating guide basically tells you that you'll need some other software, but it doesn't go much further than that. I'd like to see WizMaker and any other manufacturer of CNC machines at least put up a few tutorials on their website that will step you through some software options and the setup instructions for the particular machine you buy. Fortunately, I've already done a good bit of the learning on my own and with the help of the maker and community of my larger CNC machine. Next, the motor controller for the 500-watt spindle should really be marked with some RPM settings. It would be nice if you could still control the RPM with this upgrade, but I think that's a common limitation of smaller machines. Moving on, I did have a couple of issues with the offline controller, not liking the G-code I tried to load from the USB drive. It will go through the normal loading process and ask if you want to run the G-code, but then it'll either freeze up or just go back to the home screen and do nothing. It would be nice if it would at least give an error message or even let you know what it didn't like about the G-code. My final con, and this one is a bit tricky, is that the wonderful magnetic dust shoe doesn't extend far enough down if you are using longer bits, especially the 1/4 inch bits that I tried. Now, this could easily be solved with a cylinder extension, which I might make on my own down the road. While not a con, I should also note that the machine has a bit of an identity crisis. You may have noticed that the offline controller says Atom Stack. There are also references in the operation guide to the C4, which is that company's version of the same machine. So that wraps up my pros and cons, but let's talk about CNC machines in general. Here are a few general tips. First, buy more bits. A CNC machine is only as useful as the bits you own. Second, you will break bits. Even the most seasoned CNC operators out there break bits from time to time. Heck, I broke a bit trying to do the rotary part. Sometimes it's a silly mistake, and sometimes it comes from trying something new or pushing the machine to its limits. Next, keep scrap material for testing. Until you've tested a particular bit, speeds and feeds, and a particular material, you won't know the ideal settings. Numbers you find on the internet might be a good starting point, but you'll need to do your own testing to ensure you get the results that you're happy with. And finally, software. As I mentioned before, this is a big part of the expense of CNC machines. Do your research before you make the purchase so that you know what you need to invest to do the types of projects you'd like to do. The free software is often very limited, and you'll need to upgrade to gain capabilities. I would personally like to thank James Dean Design and the info he provided about 4th axis rotaries that I found invaluable during this review. I'll place a card or link to the video in the description below. Were it not for his video, I wouldn't have known about Desk Proto. So, thanks. In summary, after running through all 8 projects, I feel that the WizMaker Artisan 01 offers an excellent balance of capability, upgrade potential, and value. This machine ticks a lot of boxes. That said, if your workflow is heavy metal machining, large volumes, deep cuts in steel, etc., or you require very high spindle speeds and torque, you may eventually find this machine reaching its limits. But for hobbyists, advanced makers, even small product development, it is a strong candidate. So if I were to give a verdict, yes, I recommend it, with the caveat that you match your expectations to the desktop class and ensure your workflow, bits, fixture strategy, and material choice align. Don't expect a full-size industrial CNC in a desktop footprint, but do expect a lot more than the typical entry hobby machines. If you liked this review, please hit the like button, subscribe for more CNC and Maker Tool reviews, and drop a comment if you'd like a deeper dive into any of the test projects. Thanks for watching, and as always, let's keep on learning, burning, cutting and growing together. Take care, everyone.